These vehicles, they pass at a checkpoint. So the table below shows the speeds to the nearest kilometer per hour of 90 vehicles that pass at checkpoints. All right. And of course, they're going to ask us to continue filling out the table. Cumulative frequency. So 5 plus 11 give us 16. Then 16 plus 26, that give us 42. Then 42 plus 37, that's 79. Then 79 plus the 9 right here, that is 79 plus the 9. That's 88. And then 88 plus 2, that is 90. All right. And so that's what we have, 42, 79, and 88. All right, so now we finished to complete the table, and we're asked now for the class interval as written in the table. Complete the following sentence. The upper class limit. It said upper class limit, not boundary, upper class limit for 20 to 39. The upper class limit is just 39. Then it asks for the class width. The class width is going to be 39.5 minus 19.5. 39.5 minus 19.5. And so the class width is 20. 20. Then it asks 16 vehicles past a checkpoint no more than 16 vehicles past a checkpoint no more than dash kilometers per hour. Now, of course, we're in this interval, and so 16 vehicles at most past a checkpoint no more than 39 kilometers per hour. All right, because of 5 and 11. So is 16 vehicles where travel slower than 40 kilometers per hour. So that's filling out that part right there. Then it says complete the table shown above by inserting missing values, which we did already. Then it says on the grid provided on page 21, using a scale 2 centimeters to represent 20 on the x-axis and 2 centimeters to represent 10 vehicles on the y, draw a cumulative frequency. So let's do our cumulative frequency. So remember, we plot frequency on y-axis and number of vehicles on the x. That's our y-axis. And then our x-axis. So now we have our y-axis and our x-axis. Y-axis, x-axis. What's the next thing now? What's the scale again? It says 2 centimeters represent 20 kilometers on the x. So 2 centimeters represents 20, 40, 60, 80, bills, 120. That's what we have right there. 20, 40, 60, 80, 100, and 120. That's what we have right there. The next thing now we need to plot on the y now, the y-axis. Now the y-axis, what we're gonna have is 2 centimeters to represent 10 vehicles, the frequency. On the y, this is 10, 20, 30, 40, 50. So on the y right here says 50, 60, 70, 80, 90, 100. And then right here is 110. Nice and easy. So that's what we have. All right. So now, of course, let's go ahead and proceed. It says, using a scale 2 centimeters to represent 20 kilometers per hour on the x-axis and 2 centimeters to represent 10 vehicles on the y, draw the cumulative frequency of the curve to represent the information in the table. On your graph, draw a reference point to estimate this and that. So now let's draw a cumulative frequency. So remember, when you're doing cumulative frequency for x values, we use the upper boundary values. Upper boundary values are 19.5, 39.5, 59.5, 79.5, 119, 99.5, and 119.5. Then we plot them against the cumulative frequency. So let's go 19.5 and 5. So on the x, you have 19.5 and 5. 5 is going to be, this is 10, somewhere right here is 5, so it's 19.5 to 5. That's the first point. Now, second point is going to be 39.5 to 16. 39.5 is here to 16. 16 is going to be, this is 10, this is 15. So here is 16. Nice. Then next we're going to plot 59.5 to 42. 59.5 to 42. So this is 40, 41, 42. Nice and easy. After we do that now, we're going to plot 79.5 to 79. 79.5 to 79. 50, 60, 70, 80. And 79.5. So 79.5 is right here to 79. That is right here. Nice and easy. And then we have 88 to 99.5. So x is 99.5, and we're plotting it against 80. 99.5, plot against 99.5 to plot against 88. 88 is going to be, this is 90. So 88 is going to be right here. This is 88. And then the final point that we're plotting is, that looks like 90 to 119.5. 90 to 119.5. So I'm gonna make sure 119.5 is here to 90. This is 90. That's it now. So now let's plot the cumulative frequency. It should have an ogive shape. Ogive. Oh shoot, I don't like this at all. Let's fix it up. Let's fix it up. Fixing, fixing. We are going up. We're going up together. So that's what we're doing. We're just drawing. Going up, going up. Going up together. Go around here. Oh shoot. Missed the target. So we're just neating it up now. This is our cumulative frequency. So if you're wondering how did I plot these points, again, on the x-axis you plot, on the x-axis, let me put a table to represent what I plot on the x-axis. So I'm going to write a table called x-axis. X-axis. On the x-axis, you are plotting the upper boundary value. So you plot 19.5. That's the upper boundary right there. 39.5. That's the upper boundary right there. 59.5. That's the upper boundary right there. 79.5. That's the upper boundary right there. 99.5. That's the upper boundary right there. All right, these are the upper boundaries we plot. Then 119.5. These are the upper boundaries we plot. Nice and easy. Now it says, on your graph, draw reference lines to estimate the speed at which no more than 50% of the vehicle drove as they passed the checkpoint. On your graph, reference the lines to estimate the speed at which no more than 50% of the vehicles. 50% of the vehicles is the position of Q2, which is the position of the median. Position of Q2, 50% of the vehicles. How many vehicles are there? 90. 50% of that is 45, so that's right here. All right, so this is the line to estimate it. All right, this is the position of Q2. You have 90 vehicles, so this line at 45 is your position of Q2. PQ2 means the position of Q2. And then draw another line going down to see what goes with the position of Q2. Going down right here. Then that's that. So it says on your graph, draw a reference line to estimate the speed at which no more than 50% of the vehicles pass the checkpoint. So what is the estimated speed? The estimated speed is this. This looks like 62. So the estimated speed is 62 kilometers per hour. So let's write that down. The estimated speed is 62 kilometers per hour. That's pretty slow, but that's not bad. 62 kilometers per hour. Nice and easy. Soft.